All right, here is the second page of chapter 2. We left off yesterday. How do you solve a problem that has two radicals in it? You remember what you do? How do you solve this? You're going to bring this to the other side, one of them. And then you have to square both sides. When you square both sides, this side you get x minus 3. Do you guys know how to square this right here? You square the first term. It's the back of that single sheet. You square the first term. You multiply these two by 2. And then you square the last term. Now what you have to do is get x by itself. So I would cancel these two out. You want to add these two up and subtract. You get negative 24. Divide by negative 8. And then square both sides again. So you get 9 equals x plus 3. And then subtract 3. So your answer is, I'm sorry, this is a 5. Your answer is 4. Now, how do you, if you have a multiple choice test and you forgot how to do this problem, what you could do is take your answers and plug them in. It'll take you longer, so I would definitely wait. If you have to do that, wait till the end to do this problem. Number 10, this is an absolute value problem. You have to break this up into two problems. X squared minus 6x plus 1 equals 8. And x squared minus 6x plus 1 equals negative 8. You want to get a 0 on one side, factor, and solve. And you do the same on this side. So add 8, factor it, and your answer is 3. So there's 3 answers for this one. Number 11. Okay, this one is an absolute value. You're going to break this up into 3x minus 2 equals 5x plus 4, and you do 3x minus 2 equals negative 5x minus 4. Does everyone know the difference between these two?
After you find numbers, you have to go back and check.
Yes, check. These all work right here.
Okay.
This one, the 2 answers you get for 11, and you guys, we don't have time to do every single step. This answer you get x is negative 3. This one you get negative 1, 4. But when you plug negative 3, be careful with the ones with the variable here. You're going to see that if you plug, when you take the absolute value of a number, it's going to come out positive. But I know that when I plug a negative 3 here, this side's going to come out negative. So this was an indication to me that something's going to happen. It's not going to work. It doesn't. That side does not work. Negative 3. This is extraneous. Number 12 should be, that's a 9th grade question, you guys. How do you solve this? Distribute. What do you do with this negative 5x? What do you do here?
Oh, you flip the sign.
You're going to flip it. It's going to become x is greater than 6. And then you have an or statement here. You're going to solve this side. You get x is less than 3. or you put them both on the same number line, if you were to graph it. So, less than 3 is this, and greater than 6 is this, so they're both a solution. How do you express this answer in interval notation? How do you write this answer? It'd be negative infinity to 3, union 6 to infinity. Definitely use parentheses on this one. Questions? Number 13, you're gonna break this up into that 3x minus 2 is less than or equal to x plus 10. And then you're gonna do x plus 10 less than 4x plus 1. This is an and problem. So you're looking at where they overlap. On this side, you're gonna subtract x, so you get 2x, and add 2. So x is less than or equal to 6. And this side, subtract x. X is greater than 3. So where are the numbers that are greater than or equal to 6, I'm sorry, less than or equal to 6 and greater than 3? Well, they fall here. It'd be a 3 and a 6. And then how would you write this answer in interval notation? Parentheses. Whoops. My brain and my hand are not in sync today. Here you go. Here's your answer. Now 14, you should recognize, what is this? What does it look like? It's a right side up parabola. Okay, so what are the two critical numbers? Well, you have to, the x-intercepts. So you factor this out, x minus 5, x plus 2. So 5 and negative 2 are your x-intercepts. So here's negative 2, and here's 5. So this thing looks like this. This is the quickest way to do it. So we want, where is the graph below the x-axis? It's this region right here. So it's between negative 2 and 5. Why am I using brackets? Because it's including these two critical values. If it said greater than or equal to 0, I would go negative infinity to negative 2, and then 5 to infinity. So less than 0 is the part below, greater than are these branches going up. And number 15, we call this a literal equation. They're looking at, can you solve this for a different variable, not a? So what you're going to do is first get rid of 3 pi, divide by 3 pi. Now you want to remove the radical, so you have to square everything. Square this side, and you square this side. So you get a squared over, this is going to be 9 pi squared. You have to square everything. That's applying your exponent rule. And now I would cross multiply. You want to get c by itself. I would do these two together, multiply. So you have a squared c equals 9 pi b, I'm sorry, 9 pi squared b. And then get c by itself, you're going to divide by a squared. So your answer is 9 pi squared b over a squared. Okay, so chapter 2 is done. Questions on chapter 2? These tests will be available if anyone wants to stamp a picture of anything. They're here. Questions?
Did you say you had an extra?
That one? I don't, but I can make you a copy. I'll make you a copy.
Yeah, looks very
Are
This one?
they the same one?
Or is it the chapter 2?
Oh, yep, I do. It's not this. Yeah, you can take that one. Okay. Let me get on this.
Wait, there's no fix.
I'll give it to you. It's not running away, it's right there.
You know what? Can you wait till I Thank you.
There's no vacancies.
Okay.
Yeah, I know too.
All right, the next one. We're on chapter 3. Chapter 3. All right, do you remember how to do these problems right here? This will be on the calculator part. This, they're asking you, can you find the max and the min and tell me where it's concave up, concave down, find the inflection point and all that other good stuff. So what do you first do? You want to type this in your calculator. Okay? So go ahead, take your calculator, type it in. You have one. Huh? Yes, you can. But, right now, you can just hang on because I'm videotaping. All right, what you get when you type this in your calculator, you get this picture right here. Just gonna review fast. We don't have a lot of time today. You type this in your calculator. You get this picture right here. So we want the minimum, this is the picture of it. Looks like that shape. So this is your minimum value. We want this X value. So do you remember how to find these 2 points, the min and the max? What do you hit on your calculator? Second calc 0, max or min, whichever one you're finding. So I think I might have this calculator still. Oh, I don't. Oh yeah, I do. What is it? That's the equation, then you hit graph, that's what it looks like. So down here, if this thing is gonna come down, your minimum value, you hit second, calc, and do minimum. And then give me a bound. I'm gonna say -4 is the left bound, and -1, we don't have to guess. And there is your minimum value, -3.2. You do the same for your max. You hit second calc, and then hit max, and you end up with 0.5 for this one. So now, how do you describe this graph? It's increasing from -3.2 to 0.5, and remember, we don't use brackets, we use parentheses. It's decreasing from -infinity to -3.2, and it's decreasing from 0.5 to positive infinity. There's no constant on this one. Do you remember how to find the inflection point? How do you find the inflection point? You add up your 2, max and min, and divide by 2. What that tells you right here, that's your inflection point is -1.35, which my graph is not drawn to scale. It should look more like this. -1, -2, -3, it's like this. I'm not drawing a very good graph. Sorry, guys. Look at that better. So the halfway mark is about right there. I could change my window and change the y value, the minimum y value to, let's say, -20. And now, if you graph it, you might see it a little bit better. So right here at -1.5, your graph changes, it's concave up from negative infinity to negative 1.5, and then it's concave down from this x value, looks like an upside down parabola. So do you recall doing this stuff, guys? Concave up, concave down, inflection point. Okay, next. You don't have to do 2. Okay, 2 don't worry about. Now we are on the next set of problems. 3-1 to 3-3. Do you remember how to determine whether you have an equation that's a function? Well, you're gonna resolve it for y. Solve your equation for y. If y is an even power, what ends up happening here is you get you have to take the square root, which means y is plus or minus. This is not unique, there's 2 values here for x. So this one is not a function, but this one will be. So, how did we remember this? If y is an even power, it's not going to be a function. If it's odd, it's going to be a function, it's unique. So this one was no and yes. Number 5, how do you evaluate a function? Oh, that's easy. You plug that number into whichever function it is. So here's f. You're going to take 20 and square it. And then you're going to add 2 times 20 minus 4. And what'd you get for an answer? Anybody?
406.
What is it? 406? Yep. How do you do the greatest integer, that bracket? You round down. You're going to move, think of your number line. You're always going to go to the left. So what is the greatest integer of 4.789? It's 4. What if it were negative 4.789? What would it be? Negative 5. Negative 5. Round down. Number 7, not on your test. Number 8, the domain. Okay, if you have an x in a denominator, what do you do with that denominator? You set it equal to 0, and those are the areas where you need to stay away. So for number 8, what can't x be? 0. So in interval notation, it's negative infinity to 0, 0 to infinity. For number 9, you have 2 things going on. You have a radical and you have a fraction. Well, radicals, if it's a square root radical, you can't have a negative number in here. So what you do is you set x plus 2 greater than or equal to 0, subtract 2. So the only x values I can use for the numerator are numbers that are greater than or equal to negative 2. So I can only use these numbers for the numerator. But hold on, because the denominator is going to stop us from using what number? 4. We can't use a 4. So I make a little break here at 4. Let's pretend like this is 4. And you can't have 4. So my domain is going to be from negative 2 to 4, and then from 4 to infinity. Questions? Is 10 a function? That's easy, yes. Pass the vertical line test. Number 11. These are called piecewise functions. If you're going to just evaluate for a certain number, how do you know which piece do you put 2 in? It's got to go in one of these 3. Well, you look at, this is the restriction for each one. Where does 2 fall? 2 is in this category right here. So you would plug 2 in here. 2 minus 3 is negative 1. That's your answer. And -5, where are you gonna plug -5? Which of the three? The top one? So -5 squared is 25. Describe the domain of this. It's all of this. This is your domain, guys. So how would you say this short and sweet? It would be from -7 to infinity. And you would use a bracket at -7. Because it's going from -7 to infinity. Number 12, this one's giving you a picture, a function, and they want you to pick out what the y value is. They give you an x value. When x is 1, you go to 1 and the graph goes down to -3. And when it's 4, it goes up to +3. Questions? Okay, how do you graph a piecewise function? Well, this is probably not gonna be on the exam, but you should know how to do it. Bless you. You're gonna graph, that's a parabola, and you only wanna graph the numbers that are less than -1. And for this is a line, you only graph the x value, so you can make a t-chart for each of these and just evaluate numbers that are less than, you can go, this is one of the easiest ways to do this. So for x squared, only put in x values in your domain that are -1, -2, -3, -4. So you would square 1, 4, 9, 16. So when you graph it, it's gonna be half of a parabola. Then same with this, you only plug in numbers that are between -1 and 4, like -1. Well, you start with -1 and you go up to 4 in your x values, but when you graph it, you should have an open circle at -1 and a closed circle at this point because of the bar here. And then you do the same thing with square root. You're gonna, the square root one, you start with 4, the square root of 4 is 2, and the next number you can take the square root as 9, which is 3. This point would be an open circle, and then connect with 9th grade. Anyone have any questions? Next, you don't have to graph it, greatest integer or the piecewise, but you do know, go to 16. 16's a good one. You should know all of the goodies that you get with this formula. This is called transformation form. What things do you know with transformation? Well, this tells you that it's upside down. It's down. This tells you the axis of symmetry. And your vertex is 2, 3. Do you remember this? How do you find your x-intercepts? Well, you plug 0 in here. I'm just reversing it. How do you solve this? This is an easy problem. This is from chapter 2. You're going to subtract 3 and divide by -3. So you get x minus 2 squared equals -1. Oops, 1, not -1. If this were a -1, there would be no x-intercepts. Then take the square root of both sides. You get x minus 2 is plus or minus 1. And then,
How'd you get the 1?
subtract 3
Okay.
and divide by -3.
Oh, okay.
Subtract 3, get rid of these two pieces right here. You always want to isolate this, get this by itself. So subtract 3, divide by, I did that in my head. And then add, so 2 plus 1, which is 3, and 2 minus 1, which is 1. So this graph is hitting the x-axis at 3 and 1. then you have 2, 1, 2, 3, so it's upside down. Just like that. Now, how do you find the y-intercept? You plug 0 in for x and find y. So if you have a 0 here, 0 minus 2 is -2, -2 squared is 4, 4 times -3 is -12, and then plus 3 is -9. So 0, -9 is your y-intercept. Next. This is called vertex form. What do you know, I'm sorry, not vertex form, x-intercept form. This, you know your x-intercepts. Your x-intercepts are 4, 0, and -2, 0. Now what's nice about this, here's 4, 0, and here's -2, 0. This graph is upside down according to that negative, but what's the magic number in between here that gives us symmetry? You go halfway. So what's the middle number? Right there. X equals 1 would be your axis of symmetry. You split the difference. So the middle number between -2 and 4 is 1. I'm not going to go through this whole problem. You should be able to do it. How do you find the vertex? Well, there's so many ways you can FOIL this out. You can use that formula, -b over 2a. That's going to help you find the axis of symmetry, which we just figured out by just logic. X is going to be 1, and then you plug 1 in here to find the y value. That'll give you your vertex. For 18, that's in polynomial form. You should be able to graph that and tell me the vertex, axis of symmetry, and all that stuff. Does anyone have any questions? Okay, 3, 4. Here is 3, 4 to 3, 6. We did a lot of transformation stuff. There's going to be a couple questions that are asking you about transformation stuff, but it's not going to be so power-packed like these two were. It's going to probably have two or three transformations, like reflection or vertical stretch. Not, I gave it all to you. So in this one, it's asking you to reflect something over the x-axis. You have a negative in front. Up or down is this outside number here. Left, you do the opposite, that's inside of the grouping symbol. Vertically stretching it, that goes outside. Horizontally, stretching it horizontally, you flip it, and it's 1/3, that goes outside. Or inside, I'm sorry. Horizontal's inside, vertical's outside. For number 2, what you had to do is get this ready. Pull out a 2. So you start right here. This is to describe the transformation. You take this number and you flip it. It's a horizontal compression by a factor of 1/2. This is going to be opposite, so 4 units to the right. Outside, you do reflecting over the x-axis. That's a small, less than 1, so it's a vertical compression by a 1/5, and down 2. Number 3, this is a reflection over the x-axis, and you take this 1/2 and you flip it, you get a 2. So how would you do this graph here? You take it, you make a little table of values, which this is the graph right here. It's hard to see on the screen, but this is the graph. How do you do this to it? Well, this 1/2 you flip, you get 2, you multiply the x values by 2 in your table, and then you take your y values and multiply them by -1. Odd, you take all of your points and you change the signs on both of them, x and y. For odd, you change both the x and the y to be opposite. It's a reflection over the origin. How do you graph these functions, these families? Well, you want to get a table going of the parent function. We spent a lot of time on this stuff. And you just got to make sure that the a value is pulled out. You flip that number, multiply the x value by that. You add the opposite of that number to the x value. And then these outer two numbers, you affect the y value. Multiply the y value by -2 and then add 3 to the y value. And that's what this one looked like. Number 6, you do the same pull out. This is a parabola. Pull out -1/3. You multiply your x values by -3. You're going to add 3 to your x value, multiply the y by 3, and add 4, subtract 4 to the y. Number 7, it has symmetry to x, y, and origin. How do you know? You fold it on that axis. That'll help you. Odd means origin. X-axis means even. So how do you mathematically, you have to know this is on your test. How do you prove if a function has symmetry to the x-axis? You replace y for -y, and if you can get the problem back to its original, it's yes, but this one was a no. For y-axis symmetry, or if they say even, these mean the same thing, you take your x values and change the signs. And again, in origin, you do both, y and x. Okay, that's how you do that page. This is all the same. And then the last page, we have, is it time to go?
Yeah.
Okay, we'll start with 3.5 and 3.6 tomorrow. Thank you.